Hello, in this video we will be continuing our exploration of Seaborn's functions for displaying probability distributions. Today we'll talk about joint grid. Joint grid is the class which underlies joint plot, which we talked about last time. It gives us access to the internals of joint plot in case we aren't satisfied with the default behavior. First we'll need some data. Seaborn has a convenient function called load dataset, which gives us access to a library of samples. This dataset is called tips. It represents information about how much tip is paid at restaurant meals. We can invoke Seaborn functions using either NumPy arrays or pandas data frames. Since load dataset gives us back a pandas data frame, we use the names of the columns that we want as strings, and we pass the data frame as a named parameter. And you can see now that joint grid with no parameters does nothing, as opposed to joint plot, which had reasonable defaults. We just see the names of the variables that we picked and a scale from 0 to 1. If we want to get the same behavior we got out of joint plot, we pass the joint grid object plot method two callback functions. The defaults for joint plot are Seaborn's displot function and matplotlib's scatter function. If we have something in mind that's not provided by matplotlib or Seaborn, we can just write our own functions to pass to the plot method of joint grid, and then use this function called GCA for getCurrentAxis to give us access to the Pairplot axis object, which will act as a drawing context for our plot. The joint distribution part of the plot, the center of this image, takes two variables, x and y. They are arrays. In this case, they will be columns from the data frame that we pass to joint plot when we create it. Calling getCurrentAxis, and then I'll just use the scatter function again, but this time I'll give it a label so that I can apply a legend to it. The marginal part of this diagram takes a single positional variable, also an array. It will be one of the two arrays that are being compared by joint grid. And there's also this named parameter vertical, which determines where on the diagram we're rendering. This function will be called twice. Once with vertical false, that will be the top, and once with vertical equals true, that will be the side. And here we see basically the same diagram, since I used scatter and displot, but I added a legend, which I couldn't do before. The methods we pass to callbacks in joint grid, as long as they have the same signature as the methods that it expects, can be anything. We don't have to get them from Seaborn, we don't have to get them from matplotlib, they don't even have to be functions. Here I'll do it with callable classes by defining a call method. We don't even have to use the data that joint grid hands us in the parameters to these callbacks. For instance, here I would like to use the data in the smoker column of my data frame, but it's not available to me. That's okay. I can use any of the data in the function scope. Since my data variable is global here, I'll just use it. The marginal parameter is a little more complicated. It's going to be called twice, once with vertical equals true and once with vertical equals false. And that's going to tell me which column I want out of my data set. So that parameter I definitely have to use. And then when I actually do my query, I will index on one column or the other, depending on the value of vertical. The last thing I want to introduce is these two functions, plot joint and plot marginals. They do the same thing as plot, but take only one of the two parameters, and then you can chain them together. That way we can have two different representations of the same distribution occupying the same space without having to write a new function.